Good afternoon, ladies and gentlemen. My name is Friso Klapwijk. I represent the company Wavin. I am Global Director responsible for the strategy on urban climate resilience. And just to give you a short intro on Wavin, we're a global working company with production sites in more than 40 countries, active in more than 100 countries. And basically we cover everything that has something to do with water in the built environment and infra. There are four pillars that make us tick, that cover our mission. That is supplying safe and efficient water supply to people. That is improving hygiene and sanitation. That is improving building performance, and the topic of this talk today, climate resilient cities. The theme of this conference is on smart cities, smart water for smart cities. And today I promised to talk to you about smart roofs for smart cities. And I actually will get there, but I need to take a little detour to set the scene. Because if I look at the cities we have today, they might be called smart, but not on water. And this is the way we treat our rainwater, for instance. We just put it in a drain pipe and it's out of the city within no time, causing all sorts of effects on human life, pollution, etc. So the question is, what's wrong there? And to me, the key element of what's wrong there is that we're thinking linear. We're putting everything in a pipe, making this giant system, thinking in silos, drinking water, sewer water, rainwater, storm water. But the key element, how we get this puzzle solved, and how do we get this philosophy that we're working in our system differently, is by thinking way more circular. On a home level, on a building level, and we like to call it a blue puzzle, because everything is interconnected. It is not just drinking water on one hand, groundwater, stormwater at the other hand. This is all part of one big blue puzzle. And we like to be involved to solve that puzzle. We call that water circular design. That is basically the theme we're working on. And a couple of keywords there. First, most important is to catch. You need to catch the water, collect it, connect it, clean it, and control it. So basically these 5 C's cover what we think in circular water design. Catch it to prevent fast runoff, collect it to buffer it and to make it available again, connect it, maybe differently than we have connected it today, to make it available for reuse, clean it to make it available, and control it to make optimized use of the system and prevent failures. We need to do that on a building scale, on a plant scale or an area scale, neighborhood scale, and also on city scale. And if you think in cycles on all these different levels, then you're basically also are able to cover all sorts of water streams. It's not just drinking water, it's not just storm water. These things are interconnected. So to us, understanding the water balance on this building level, on this home level, on neighborhood level, on plant level, on city level, that is essential to make a new type of design. And if we then understand that water balance, then we can actually design a system that is able to close that water cycle. So that leads from a good water analysis to a good design that needs smart solutions. And that's what we're set out to do. As Wavin, we have a suite of solutions to solve and help this blue puzzle be solved. Okay, that was a detour. And I promised you to get to the smart roofs part. That is the number 12. The theme is smart blue-green roofs. There's a lot of words. So let me pull that a little bit out. I think you're all aware of the concept of a roof garden and a green roof. If you look around in Copenhagen and you find the time to visit one of these beautiful roof gardens, you will find a roof garden. But I need to make a really important distinction. We talk a lot about roof gardens as green roofs. Green roofs and blue roofs are two completely different things. They look a little bit the same, but the key element, here you see a green roof. Not a pretty one. This basically is broken. And the reason why is because the way it's been built up. This is how the full industry works on green roofs. Of course there's vegetation, there is some sort of growing material, substrate, but this is the essential layer. Traditional green roofs have a really shallow, non-buffering drainage layer. So if it rains, of course, this will get soaked. And there will be some sort of green, there will be some sort of evaporation, there will be some sort of stormwater management. But by the time 2 days after the rain event, the whole system is dry and you get to see this picture. A blue roof has one distinction from a traditional green roof solution, that it has a full buffer layer underneath your substrate, underneath your growing material, catching basically the rainwater, collecting it and making it available for reuse. So this is how that looks like. This is a 2,000 square meter roof, and with adding a buffer layer of just 80 mil, we're able to capture more than 100 cubic meters of rainwater. That's a lot. And you can basically build anything on top of it. This is actually like Lego. I'm in Denmark, so that should be a good reference. You can build basically anything on top of it. And we create beautiful roof gardens. People always say, Friso, blue roofs, those are the heavy ones. Not all the roofs can capture it. But the actual fun is, we create the same roof garden in terms of weight with a blue-green roof solution than with the traditional green roof solution, to create the same image on the planting. Why? Because we're way smarter with the water buffer system. What do plants need to thrive? Water, more than growing medium. So that's the trick. And the key element, and we didn't draw this circle on purpose, we're creating this water cycle on rooftop level. Okay, next step. The difference between a blue-green roof and a smart blue-green roof, because that's what we're to present. Basically, it is the same as a blue-green roof, but then connected to the internet and controlled. And at Wavin, we like to call that a Polder roof. A what? Well, have you ever been to the Netherlands? This is how we've built the Netherlands. It used to be ocean. We built a dike. We pumped out the water with a mill and created fertile land. Okay, half close your eyes and look at this and imagine a building. You see a rooftop, a flat piece of land, surrounded by a dike, a roof edge. Well, the trick we did is we added a mill. This, in 4 icons, is a smart blue-green roof. Adding a water retention zone, a buffer zone, adding a smart control, so you can actually control the water level, like a mill. Connecting it to the internet with a set of sensors, you can have actual data on the roof, and also include forecasting, so you can be smart, even more smart with water. And then it gives you the ability to control from a distance. Open, close, connect, and reuse. I don't know how many technicians are in this room, but I would like to go a little bit deeper to explain why we call this part of the blue-green puzzle, the blue puzzle. This is one of the buildings we put up in Amsterdam, or not, it has been put up by a general contractor, of course, but this is how we like to talk in the building industry. Yeah, this is my building, I built this. Okay. We have built here the rooftops. This is the top roof up here. This is a blue-yellow roof, as we like to call it. So there's a buffer system. Here you can see it's not a mill anymore. We changed it into a drop. Some people didn't like the mill. This is blue-yellow because it has a water buffer and it has a solar system. And then on all the balconies here, you see the dots of green. This is what you see here. Every balcony has its own little planter. It's actually quite a huge planter for a balcony. So what we've done is made this into one water cycle on building level. So the top roof collects all the water, catches the water, collects it, and through a cascading system through the planters, it runs down. And on the lowest level, here's the smart drop, controlling the water level on the top. And here on the lowest level is what we call a smart level. And the only thing the smart level needs to do is tell the system, Acora, when the water level is to 0. And then the valve opens here and recharges the buffers, cascading down until the level says, I'm up to 3 centimeters, and can close again. Cool, huh? This is not the only one. We're working on multiple tens of these type of projects. So this is the data. I made a screenshot of, let's say, the last month. And here you see the water height. This is Aquara, by the way, our software system that controls the water. So every time the water level spikes, there has been a rain event, as you can see here. This is the actual rainfall. And every time you see it declining here, the valve opens to fill the buffers on the balconies. And every time you see it declining a little, that's evaporation. So we cover the water height and the rainfall. That helps us and also to predict when to open and when to close. Oh, sorry. What is interesting is this is the temperature on the top roof. I don't know who of you have ever been on top of a black roof during a summer day. It is awfully hot, isn't it? 60, 70 degrees is not an exception. So this is a screenshot of summer in the Netherlands. Okay, this is not, it's not Madrid, okay, but it was still pretty hot in the Netherlands. The temperature on the roof didn't exceed the 27 Celsius. And remember, there were solar panels on top of that blue-green roof. Solar panels, when they got hot, their efficiency drops. So by cooling the solar panels, we had higher revenue on the solar panels. And it cools, of course, the building. And then one interesting last thing to show here is this is a screenshot of the full year, full growing season. And these are the 3 moments, 1, 2, 3, when we needed to open the tap, because we had a system that basically to prevent when all rainwater was evaporated, we still want the plants to thrive. So we included a smart tap, as we call it. 3 moments we needed to add water to the system over a full growing season. Well, one of the paradoxes of creating a smart green city is that we need way more water to keep this green alive. But with these type of systems, as we present here today, I show you here basically that we reduce to the minimum the amount of drinking water we needed to add to the system and still have that enormous evaporation capacity. And this is how it looked 2 weeks ago. This was sent to me by one of my team members. And you see how this green explodes. So that was my key message today. We believe that with our Polder roof system we can really add value to smart and green systems. And just to say about the blue-green puzzle, that is not just on a building scale. You can easily extend this. If you would connect these roofs to an attenuation tank, to an infiltration tank, feed your trees with it, irrigate your lawn, wash your car, connect to the toilets. These type of thinking, that is, I think, what we need in our smart cities. Thank you.